Now we're going to look at catalysts, which lower the activation energy by allowing a new pathway for the reaction to follow, which has a smaller energy of activation, which is shown as delta G+. Catalysts will participate in a reaction, but one, not consumed nor changed in the reaction. They are regenerated at the end. I'm going to say but are not. Okay, so a catalyst will participate, but it is not consumed or changed in the reaction. They are regenerated at the end. Okay, they only participate. They're not changed nor are they consumed. Okay, so energy of products and reagents remain unchanged. Right? Reagent, product, same. High energy, low energy. The beginning and the final will be the same. Energy of activation is the only thing that changed in a catalyst, delta G+, right? This is the only thing that changed, high energy, low energy. Okay? So catalysts affect rate, kinetics, not the amount of product formed. And we see that thermodynamics is not impacted, right? Right here. Okay, so only the kinetics, which is how fast it's going. Okay, this is fast, slow. Okay, so next we have enzymes. They are substrate specific. They're biological catalysts. Substrate need to be transformed into products of some kind, right? So a substrate has to have an enzyme, which is a catalyst, in order to produce that product. Okay, so a substrate is the reactant of the enzyme catalyzed reaction. Okay. The active site is the pocket in the enzyme where the substrate binds using intermolecular forces. So this big old thing is an enzyme. The substrate comes in and binds right here through intermolecular forces, right? IMFs. Okay, and again, let me reread this, is the reactant of the enzyme catalyzed reaction. So this enzyme is a catalyst. Enzyme is a catalyst, and this substrate needs to be turned into something else. So it binds into the enzyme so that it can be transformed into the product, right? Next, we have an example with a lysozyme. So cell walls have thousands of six-membered rings linked by oxygen molecules. Lysozymes, which are enzymes, because of that zyme, cleaves bacterial cell walls by breaking the bonds that hold these six-membered rings together. And this locks the substrate into the active site through intermolecular forces. Okay, again, that locking of the substrate, oh, that's bad. Of the substrate, this is the enzyme, and oh, okay, let's let that disappear. Enzyme, substrate, binding right there, right, through intermolecular forces. The IMF brings the substrate into the active site at a very precise location, okay, which allows the enzyme, in this case lysozyme, to facilitate a reaction. And the enzyme itself brings in two catalysts to the active site of the enzyme to facilitate that bond. It's going to be an acid catalyst and a nucleophilic catalyst. And remember, nucleophiles can also be pi bonds. So catalysts lock substrates into the active site through intermolecular forces, and they bring catalytic components into that active site through different amino acid combinations.